In this episode of Cube FM, our guest, Nick Nikitas, who is a senior platform engineer at BlueGround, shares his story about the challenges he faced with static pre-production environments, how his team tackled performance bottlenecks, and why deployment previews have transformed the developer experience. We'll discuss questions like, what led BlueGround to rethink static pre-production environments? How did they navigate the costs and complexity of multiple environments? And what unique solutions emerged from implementing Kubernetes-based previews using GitOps, Argo CD, and Velero? This episode is packed with lessons on balancing cloud costs, reducing friction in deployments, and crafting scalable strategy for production-like previews. If you're looking to optimize your Kubernetes setup or just stay up to date with cloud-native tech, you'll definitely enjoy our conversation. This episode is sponsored by Loft Labs, the creators of vCluster. How are you managing multi-tenancy in Kubernetes? Namespaces can be insecure and lead to noisy neighbor issues, while provisioning separate clusters is expensive and an ops headache. vCluster solves this by running secure, isolated virtual clusters on your existing infrastructure, saving you time and money. Virtual clusters launch in seconds, offer better isolation, and scale effortlessly at a fraction of the cost. Try it for free at vcluster.com. Now, let's check out the episode. So, Nick, welcome to Cube FM. What 3 emerging Kubernetes tools are you keeping an eye on?
Yeah, so one of the tools that I keep an eye on is Karmeter, which is a Kubernetes native autoscaler developed by AWS. It offers advanced autoscaling capabilities by automatically launching the right compute resources for your workloads based on their specific requirements. I believe that after the recent Karmeter's graduation from beta, its new features regarding the disruption regions and the consolidation control will allow users to implement a better fine-tuning towards the improvement of the balance between cost efficiency as well as application availability. Another tool that I would like to mention is Traefik, an open-source cloud-native load balancer that is commonly used as an ingress controller in Kubernetes clusters. Traefik supports self-termination and uses service discovery to dynamically configure routing, which pretty much simplifies traffic management across microservices. And finally, for the last few days, I've been interested in Argo Rollout, which is a Kubernetes controller that provides advanced deployment strategies for managing the rollout of applications in a more controlled and progressive manner. Since it supports more sophisticated features like blue-green canary deployments, I believe that it brings a lot of value to production environments, allowing for safer, more gradual releases with the ability to pause, monitor, and roll back your changes based on real-time data.
Now, what do you do and who do you work for?
So I'm a senior platform engineer at BlueGround. BlueGround is a Greek company that specializes in offering fully furnished, flexible rental apartments for medium to long-term stays with flexible lease terms and operates in numerous cities worldwide. Our platform team at BlueGround manages the cloud infrastructure that allows development teams to build, deploy, and scale applications smoothly. It's responsible for the CI/CD pipelines, the monitoring and observability of the overall system, as well as the improvement of the developer experience by providing several internal automation tools.
And how did you get into cloud native?
Yeah, well, during my studies for my Master of Science in Machine Learning and Data Science, I was experimenting with Docker Kubernetes. So I decided to implement a thesis that would combine both some big data technologies like Apache Spark, as well as several DevOps tools. And I became increasingly interested in cloud technologies and the whole process of deploying and orchestrating distributed systems. That led me to dive deeper into the cloud native ecosystem, focusing on tools and technologies around containerization, infrastructure as code, as well as automation with CI/CD pipelines.
Now, the Kubernetes ecosystem moves very quickly. How do you stay up to date? What are your go-to resources?
Yeah, staying updated in the Kubernetes cloud native ecosystem is crucial because it's constantly evolving with new tools. What I regularly do is to visit relative blogs of cloud providers like AWS. I also read the topics of conferences like KubeCon and listen to the presentations that I'm interested in, so as to get a better understanding of possible tools that I would like to get my hands on. And finally, I have subscribed to several newsletters like Cube Weekly to get a short list of important news frequently.
Very good. Now, if you could go back in time and share one career tip with your younger self, what would it be?
Well, I would tell my younger self to actively seek out mentors and communities, because I believe that learning from others' experiences and sharing knowledge in a community can accelerate growth and open up opportunities I wouldn't have found on my own.
Good advice. As part of our monthly content discovery, we found an article that you wrote titled 98% Faster Data Imports in Deployment Previews. So, in 2022, BlueGround faced challenges with their static pre-production environments. Can you walk us through what those challenges were and why they became a problem?
Yeah, although we had the 1 to 2 dedicated pre-production environments for each engineering team in our Dev Kubernetes cluster, we noticed that there was an informal blending of environments between teams. There was often miscommunication between them when there was a need for ad hoc debugging. Also, the developers in a team would start implementing several features at the same time, so a static environment would end up being feature-specific. So this structure was not scalable and maintainable at all.
Sounds like a frustrating problem for developers. What options did you consider to solve this, and how did you arrive at your final approach?
One way we considered to tackle this problem would be to spin up more fully fledged pre-production environments per team. But this would result in higher cloud costs, since we had to allocate more resources that would be available 24/7. In addition, having these static environments as shared between more teams would worsen the issue regarding how they could do their work in a frictionless manner without blocking each other's feature development. So we decided to implement our own flavor of deployment previews, on Kubernetes specifically, inspired by platforms like Vercel and Netlify. The decision was made because we believed that having an ephemeral self-serve environment would greatly improve the developer experience, as well as reduce maintenance and cloud costs.
Implementing deployment previews on Kubernetes sounds pretty complex. Can you tell us what the tools and technologies you considered and why you ultimately chose GitOps and the specific tools you did?
Yeah, well, we realized pretty soon that there was a fair amount of implementation effort required for us to create a custom solution of deployment previews suited for our needs. One solution, for example, would be to utilize Terraform and do something like a Terraform apply, a Terraform destroy on the fly. But ultimately, since we have already adopted Argo CD for a GitOps approach in our tool stack, we thought of Argo CD application sets, and especially the pull request generator feature, which was very handy for our case. An Argo CD application set is a Kubernetes CRD, where its purpose is to automatically generate Argo CD applications. Regarding our stack, we think of an Argo CD application as a fully fledged environment that hosts the whole product. And also the BR generator was really convenient for us, since it could automatically discover open pull requests within a repository with a certain label and generate an Argo CD application.
Now, I do have to ask one question that's not on script. Did you ever evaluate Flux? And if so, what was the deciding factor that made you choose Argo?
Well, from the start, we read a lot of docs about Argo CD and how easy it is to integrate it in your stack, in your tool stack, and worked with the infrastructure as code, follow the GitOps principle. So we decided to just use Argo CD instead of Flux.
That's a great use of existing tools. How did you handle the actual deployment process and ensure that everything was set up correctly?
Apart from the aforementioned Argo CD features, we also used Argo CD waves to ensure ordered deployments. We wanted the preview environments to be as generic as possible. So, for example, for some environment variables of specific applications, we had to do some conventions based on namespaces. So we managed to make them pretty dynamic. Also, the process of Docker image building and pushing to AWS ECR is handled by GitHub Actions. And after the completion of this pipeline, the developer waits until the Argo CD application is healthy, and the comment on the APR is added that contains information around the deployment result, which is either the available points of the services or a failure message due to time.
You mentioned using Argo CD Waves for your deployment approach. Can you elaborate on how this works for people that might not be familiar with it and why it's beneficial for your preview environments?
For sure. Argo CD supports executing sync operations in steps. So within a sync phase, you can have one or more waves that ensure certain resources are healthy before subsequent resources are synced. It can be combined with resource hooks, such as pre-sync or post-sync hooks. This feature played a crucial role in our case, since we wanted, for example, to deploy our self-hosted data source, wait until they are healthy, then seed them with de-identified production data, and as a final step, to deploy our services.
Now, managing these preview environments must have been challenging. How did you handle environment termination to keep costs under control?
Yes, managing preview environments was definitely a challenge, especially in keeping costs under control. The key question was figuring out the right time to destroy the deployment preview. So initially, we relied on the Argo CD application set controller, which would automatically terminate the preview environment when the associated pull request was either closed or not labeled. However, this alone wasn't sufficient to address our concerns, particularly with long-running or forgotten PRs. So we needed a more versatile termination strategy to further reduce costs and limit the number of long-running PRs. So to address this, we introduced some additional conditions, which were a TTL of 48 hours for each preview environment, and the FIFO queue that enforced a global limit on the number of active preview environments at any given time. So to implement this, we set up a Jenkins pipeline Jenkins job, which runs at specific intervals, that removes the label from the open pull requests when either the TTL or the capacity criteria are met, which then triggers the preview environment's termination.
Sounds like you had a solid system in place. However, in 2023, you mentioned that you identified some performance issues. What were these issues and how did you discover them?
Yes, at the end of 2023, we did some user interviews where our colleagues could share their biggest pain points regarding developer experience. As we found out, the time required to have an available preview environment had become a serious performance bottleneck, since it needed more than 20 minutes to complete. Actually, some people told us that sometimes they refrained from using them when they were in a hurry. The main issue was the actual seeding process of anonymized production data in our ephemeral environments using some PG restore commands. So scaling proved challenging since data import duration was increasing proportionally to the ever-increasing size of our databases.
Quite a substantial wait time. What was your initial approach to addressing this performance bottleneck?
So we explored several potential solutions to optimize the data import process. As a first potential solution, we thought of the Kubernetes snapshots and the container storage interface snapshotter, or else CSI snapshotter. Since we have a self-hosted data source in our pre-production environments, we utilize persistent volumes and persistent volume claims to dynamically create a cloud provisioned volume through the CSI driver, which is AWS EBS in our case. So we thought of taking a snapshot of a PV, and on every restore, we would just refresh the PVC of the data source with the new data from this snapshot. However, we encountered a problem, a limitation there, that the snapshots are namespaced. So we couldn't restore a snapshot in a new ephemeral environment, which would totally fit in our case.
Given that limitation with PVC snapshotting, how did you eventually solve the problem?
So we finally read more about Velero, which has the flexibility to back up any Kubernetes resources and store them in a storage system like AWS EBS, and provides a seamless restoration in any chosen namespace. So we thought that it would be a perfect candidate as a solution there. So we deployed Velero using Helm in our Kubernetes cluster with some required plugins through its Helm chart. We also used the AWS EBS CSI driver to manage the lifecycle of the EBS volumes, as well as a snapshot controller to capture any events regarding volume snapshots and volume snapshot contents.
That also sounds like a significant change to your infrastructure. Can you walk us through how this new system populates data in your preview environments?
For sure. So we had already in place a process that anonymizes and exports data on AWS S3. So we created a new isolated namespace where a scheduled data export job is executed, and then an EBS snapshot of the PVCs and the PVs there is performed with Valero CLI. And this actual namespace is the base for each volume restore operation. So when a preview environment is spinning up, a new ephemeral environment, we still use Argo CD waves to create everything in an ordered manner. So as a first step, Kubernetes job is triggered to start the Valero restore operation using the generated snapshots from the existing backup volumes in our base namespace. It then provisions the relative PVs and PVCs of the target ephemeral namespace. And as the next wave, our data sources are provisioned, are becoming healthy, and then our applications are being deployed.
That's an impressive optimization. What kind of improvement did you see in terms of performance?
So with all these changes, the new introduction of these new tools, we managed to reduce the data import operation time from 19 minutes to a maximum of 25 seconds, actually. This optimization had a huge operational efficiency for our engineering teams, since it dramatically increased their productivity and enhanced the developer experience. As a result, our teams now strongly prefer using our preview environments, as they can achieve much more in less time.
Those are fantastic results. Now, looking back on this journey, what would you say are the key takeaways for other teams looking to implement or optimize their own deployment preview systems?
So I think that the biggest takeaway from this journey is the importance of cross-domain collaboration involving teams across the different domains, whether it's the engineering, DevOps, or product, ensures that we uncover and address pain points that might not be visible in isolation. Feedback from users is also essential and helpful because they often identify inefficiencies or areas for improvement that we may overlook from a technical perspective. Another key lesson is the value of leveraging existing tools rather than reinventing the wheel. For example, in our case, we utilized tools like Argo CD and Jenkins that we had already integrated in our stack to create a more robust system that managed to have a huge impact on the overall development process for our teams.
Oh, quite the experience. You know, we checked out your LinkedIn profile, and it looks like you're quite a fan of Rust. Is that correct?
Yes, it's been really fun diving into a new language after a few years, actually. Over the last few months, also our platform team has been integrating more and more internal tools written in Rust. It has become a key part of our tech stack due to its performance benefits and memory safety guarantees. One of the most exciting projects we've worked on recently is Rust Witcher, which is a new data anonymization tool that we developed from scratch using Rust. It is now open source. So if you are interested, you can. We have actually published an article about it on our engineering blog for BlueCloud, so you can take a better look at, see the technical details that we dive deeper there.
What's the best way for people to get in touch with you?
Yeah, I use the LinkedIn platform very often, so feel free to get in touch with me there.
Okay. Nick, thank you very much for sharing your time and knowledge with us today. Look forward to crossing paths in the future. Cheers.
Thank you very much, Bart. It was my pleasure.
Excellent. Take care. Cheers. Bye-bye.